All right, let's dive right in. Today, we're not just doing math, we're cracking open a secret vault, and I'm handing you the keys to something seriously powerful. Your very own secret math toolkit.
Oh yeah, this question, we've all been there, right? You're sitting in class, staring at a page full of numbers and weird symbols, and you can't help but think, seriously, when am I ever going to use this? It feels totally useless, like some kind of chore.
But what if, just what if, we've been looking at it all wrong? What if math isn't a subject you have to pass, but a collection of secret codes? Tools that let you do some pretty amazing things, like predict the future, decode hidden relationships, and even measure the impossible. So come on, let's open up this toolkit and see what we've got.
Okay, first tool out of the box, the future predictor. This thing is all about seeing what's coming down the road using something called exponential growth. Now, that sounds super technical, I know, but trust me, it's the secret engine behind everything from viral videos to how your money can grow in a savings account. I mean, just look at the world around you. Think about insects. Maybe one population booms, or maybe it crashes. And because everything's connected, that one change sets off a massive chain reaction. Well, here's the cool part. We can actually use math to predict exactly how that whole chain reaction is going to play out. And this is the code to do it. Now, I know, it looks like a formula, but don't tune me out. It's actually just four simple pieces. You've got your starting point, how much you have right now. Then there's R, the growth rate, how fast is it changing? T is just time, how far ahead are we peaking? You put those three things together and boom, it spits out your prediction. It's that easy. And if you want to see just how powerful this is, get this. There was a small town in Texas that started with only 1,000 people, but it grew at a steady rate of 6% a year. After 110 years, it exploded to more than 735,000 people. That is not a small town anymore. See? That's the incredible power of this tool. Okay, so we can see into the future. Pretty cool. But what about understanding what's happening right now? That's where our next tool comes in. We call it the relationship decoder, and it helps us see all the hidden connections between things, especially when a bunch of different factors are all mixed up together. So, to get how this works, we just got to start with two simple ideas. First, you've got direct variation. That's easy. When one thing goes up, the other thing goes up too. The more you study, the better your grade. Makes sense. Then there's inverse variation, which is just the opposite. When one thing goes up, the other goes down. Like the more people you have cleaning a room, the less time it's going to take. And now for the good stuff, joint variation. This is where things get really interesting because it's when one outcome depends on multiple things at the same time. Think about building a house. The time it takes depends on how big the house is and how many workers you have. It's just taking those two simple ideas and mushing them together into one awesome tool. All right, let's put it to the test with a real-world puzzle. So, the time it takes to frame a house goes up with the size, but it goes down with the number of framers. We know 3 framers can build a 2,000 square foot house in 6 days. So, can we figure out how long it would take 6 framers to build a way bigger house? And boom, the answer is 7.5 days. Just like that. The relationship decoder took a messy problem with a bunch of moving parts and gave us a perfectly clear answer. No guesswork involved.
Now for our final tool, and I gotta admit this one's my favorite. I call it the ultimate measuring tape. This is what you pull out when you need to measure something you literally can't reach. The height of a massive tree, a skyscraper, or even a kite. This is where trigonometry, or Trig, becomes your best friend.
So picture this. You're flying a kite. You can tell it's about 20 feet high straight up, and you know the angle the string is making with the ground is 32 degrees. But how in the world are you supposed to measure the actual length of the string while it's way up there in the air? Seems impossible, right?
Well, it's not impossible if you know the secret code. It's a little chant. Go on, say it with me. So ka toa. If that's too weird, just remember this sentence. Some old horse caught another horse tripping over apples. That silly little phrase is the key that unlocks this entire puzzle.
See, each part of that chant stands for a simple ratio. SOH tells us that the sine of an angle is just the length of the side opposite the angle divided by the length of the hypotenuse. CAH and TOA give us the codes for cosine and tangent. These 3 little codes are all you'll ever need. Okay, so back to our kite. We're looking from that 32-degree angle. We know the length of the side that's opposite it. That's the 20-foot height. And the side we want to know is the hypotenuse. That's the string itself. So, which part of our secret code uses opposite and hypotenuse? So we know we have to use sine. We just plug our numbers into that sine ratio, do a quick little calculation, and there it is. The kite string is almost 38 feet long. We literally just measured the unmeasurable, all while keeping our feet on the ground. How cool is that?
So we've just used 3 amazing tools from our kit: a future predictor, a relationship decoder, and an ultimate measuring tape. But here's the real secret, the key that ties them all together. They aren't just random tricks. They're all part of one huge idea called mathematical modeling.
All mathematical modeling means is taking a messy, confusing, real-world situation and translating it into the clean language of math. Every tool we looked at does exactly that. It turns a real-world puzzle into a math problem that suddenly you have the power to solve. That's not just a school subject. That's a legitimate superpower. So the next time you find yourself thinking, when am I ever going to use this? I want you to remember this. Math isn't just something you learn. It is the language the entire world is written in. And when you learn it, you get to read the code.
So the real question was never if you'll use this stuff. The real question is how. You've just been given a brand new toolkit filled with some seriously powerful gear. So now that you have the tools, what problem will you solve?